So yeah, welcome to this session where we're going to dive into AVD and give you a brief introduction to what AVD is. So someone the other day asked me, what is AVD? And I've not really dived into it myself, so I thought it would be a great opportunity to get the guys from Arista on, so Cole and Fred, to kind of just dive in and just explain what AVD is. So welcome, guys.
Thanks, Rick. Always happy to talk about this topic with anyone, so it should be fun.
And the crazy thing is we just said, well, we do it in about 30 minutes or so. But for you guys, this is something that you've probably been working on for years and years, right? So to kind of talk about this in 30 minutes probably seems quite pretty quite difficult for you guys as well, right?
I think we'll manage, and we can always follow up with anybody out there who wants to go into deeper dives. They can all reach out to us, and we can get into the weeds a bit more. But we can at least get a high level, I think, description of what things are and how things work.
Yeah, cool, good stuff, good stuff. So at a high level, what is AVD?
Yeah, so I'll take a stab at this, and Carl can definitely clarify anything that I miss. But I like to think about AVD, and we'll break out the acronym. It's Arista Validated Designs, and I like to think of it first and foremost as sort of a abstracted network model, right? So it's a way for us to provide parameters to our automation frameworks to allow us to generate configurations and documentation and tests, all of these things from a high-level network description. And I think that's what sort of separates it from a lot of the things we see out there in the world, where people will have Ansible collections and Ansible playbooks and things that deal with configurations of devices on a device-by-device basis. But what the AVD team has really done here is taken that up a few notches to where we're working with network abstraction. So I can say, hey, and like at this example we have here on the screen, this is the routing protocol I want to use and the AS range I want to use. And I can specify these network fabric parameters that will then translate into individual device structured configurations and then into actual configurations for the boxes. So I think this abstracted model approach to AVD is really where it gets its power from and kind of separates from the rest of the stuff out there. Anything you want to add there, Carl?
Sure. And I think, what we offer is obviously building configs, doc tests, but also easy integration with either deploying directly to our device or via CloudVision, right? So making it easy to onboard our customers with a DevOps infrastructure as code approach so that they can focus on culture and process and not worry about all of the writing templates, writing code. So we try to do as much heavy lifting as possible to enable them with this project, so we can build CI/CD pipelines for them, right? And really spend some time automating their end-to-end infrastructure needs.
Okay, cool. Because I know with device modeling or just like network modeling, that's quite a big thing in itself, right? So you guys kind of taken that and have kind of already solved that already, then that's a big thing. So you could kind of say this is a little bit like infrastructure as code. Obviously, it's not pure infrastructure, more network as code, right?
Yeah, definitely. This definitely is a great way to implement network as code, or you can stretch the infrastructure piece to include networking and have it be infrastructure as code. And I think the thing that we're highlighting here as well is not just the configuration that gets output here. So as you'll see on the very bottom of this diagram, because we take this sort of structured model approach to how we build up the configurations, we can also automatically generate documentation. I think all of the network engineers out there will relate to the fact that no one likes to do documentation, and very few of us are good at it. I think most of us have out-of-date network diagrams and whatnot out there. So having the documentation just get auto-built whenever you make a automation change is pretty powerful. So now your docs are up to date and they're version controlled along with everything else. So I roll out my new VLAN configuration the docs, the CLI, and everything get rolled out as one big package. So we definitely encourage version control, Git, those kind of workflows here. And the other thing is we auto-generate tests. I think Carl has some great numbers he could probably throw around with, just by using this framework, we'll automatically build hundreds, and I think in some cases thousands of tests.
Millions, actually.
just from the network design that you input to the model, right? So you don't have to go and manually create all of those individual smoke tests. We'll give you bunches of them out of the box. Obviously, you can augment those with other tests, but we'll give you, sanity checks as to, is my BGP neighbor up, and all these kind of things that you would normally want to run as part of your automation rollout.
That sounds cool. So, like first of all, with the docs, with the documentation. So you said that is is that Markdown?
Yeah,
That's generated. Okay, cool. So yeah, so you can put that into Git. So that's okay. That's cool. And then with the test. Oh, sorry.
Yeah, no, I just wanted to add, like, we natively create Markdown, but because we have this tier of structured device model that we create from our network model, we also, when we work with customers to integrate with other systems, is we can take that data, push that data into Netbox, into Nautobots. I've done integration with Infoblocks, and it's really not that hard because we have all of the device level model in a structured format, right? So it's very easy to also populate other sources of truth with our information.
Okay. Well, that's cool, because I know that's one of the things that is what a lot of folks are kind of looking for as well, is that kind of that population of something like, a source of truth, something like Netbox, which comes with its own. I mean, there's quite a lot to, when you want to do that, right? So, that's cool. That's cool. So you can synchronize this out to other systems as well.
Yep.
Yeah, you could pull from other systems to fill in these variables, or you could also push back to other systems to keep things in sync and up to date.
So with the testing, what tests do you generate? And when I say that, is do you create say like a set of YAML like kind of artifacts, if you like, that you can then supply in something like PyTest, or have you got like your own inbuilt testing like framework or tooling that is used for testing?
Let me take that one, Fred, because this is an evolving one. So initially, and what's available today is we would basically take the structured data, create tests natively with kind of the Ansible framework and asserts within Ansible. And we would do testing and we would look at the configuration, say like, oh, your router BGP is configured. These are the neighbors. I'm going to test and make sure all these neighbors are established. I look at all my point-to-point links. I'm actually going to initiate a ping on the device, gather the result, assert the results. So that is the current form. What's actually in preview today and the latest version of AVD is our integration with another test framework that we have called ANTA, which is our own test framework for network testing, which is all Python based. And in that case, the role of AVD, we basically create this intermediate step to create the ANTA catalog. So basically from the AVD models, we look at creating all of the catalog of tests to run in ANTA, and then ANTA has its own, engine to basically exercise the tests directly on via eAPI, right?
Okay, cool. So when you create, so it automatically creates all the tests, and in terms of the intended state, how does that work? Is it like you run this against your network and it takes that as like an intended state, populates some files, and then you can kind of modify that? Or could you even link this in something like Netbox?
So I mean, so AVD acts as your authoritative system of record, right? So that is the intended state that we have, and the device model we generate the 100% of the configuration, so we know exactly what device should be. So as soon as we've finish the deployment and we can look back at this model and basically generate, as I said, the catalog. The catalog will say, okay, this is the show command you need to run. This is what I expect the results to be. So then I run I grab the show command outputs that I need and then assert against, what I intend the network to be. And let's say I'm in the step where I run this before pushing my changes. I'm going to, say like, if I wanted to create a VLAN and the VLAN doesn't exist, it would give me an error message saying, hey, that VLAN does not exist on your box. So it's also a way to validate that your intent is accurate and done. But also we can identify, we do like an LLDP test where we validate our connections. So we can identify to a cabling person like, hey, you've miscabled this, and the error message will also tell you in the report where it's connected to now and where it should be connected to, right? So we can give that report directly to the tech and say, go fix the cabling, which is very common when we're standing up a new fabric, right? It's very easy to crisscross a fiber cable.
Okay, cool. No, that's really good. So you don't just kind of literally. I was just saying my internet connection was unstable. Then if I start chopping up, then just let me know. So yeah, you don't just kind of look at the configs and whatnot. You actually then do some heavy lifting in terms of figuring out what's connected to what through. So is that via? Do you stitch together like multiple different tables, or is it predominantly just like LLDP and just that kind of that neighbor data?
Yeah. So the key thing is how we generate the tests, right? So again, I'm going to go back. We have from our network-wide models, we create these, what we call the structured configuration, right? Which is, if a device has 10,000 lines, this file is going to have 10,000 lines, right? It has all the information about what we want the configuration to be in that structured format. Plus, we add other metadata that is not related to the configuration, but that we use for either documentation or testing. So we will tell on on this file, it will say, the peer is, spine 2 for this interface. So when I'm running creating my test catalog, I'm using this metadata that knows some network-wide information that I need to build my test, to build that test to then I'm just running show LLDP neighbor, grabbing that data, asserting, based on what I've supplied in the test catalog. So that that middle ground of what helps us get to the device config, the markdown documentation, and it's like super critical to also build that test catalog. And that's really the secret sauce in AVD, in my opinion, right? That allows us to scale to all these other systems as well and other use cases.
Okay, that's really interesting. Yes, because you guys are, if you like, the authority for generating the config, you then use that to your advantage to be able to, like you say, put in the metadata to be able to help you along that journey of like testing, etc.
Exactly.
So, right. Yeah, and we can exercise multiple things, right? So you can do a show commands and check the routing tables, do a show command and check your BGP neighbors, to Carl's earlier example, do pings, do all kinds of stuff that you just just think about what your normal network engineer does when they make a network change. They're going to run a handful of commands just to make sure everything looks good. We automatically build those tests for you. And then if you put this into kind of a virtuous cycle of a CI framework eventually, now you auto run those tests, automatically make sure everything looks good, and automatically roll back the network if something broke. So it really can become a powerful tool to have generated tests that get run every single time you make a network change, right? As a human, I might forget, switch over there to make whatever I changed on this have some kind of ripple effect on some switch in another data center or something. But if we're going to run every test every time, that gives me the confidence that, hey, yeah, your automation, whatever you did is doing what it's supposed to do.
And I'll like to add, you could run these tests at any given time if you're, let's say, in a situation where you're experiencing a network outage and you're trying to find out that needle in the haystack. You could just start running our post validation job really at any time, just like what's the state of the network. And it, beyond, I guess, the test we think about, we also test hardware type events like all the power supplies running, or what's the status of the fan. So all the things, the parameters that are, we would also have this in CloudVision in our monitoring system, but having a test that gives you a pass fail and a report of that is extremely valuable, right?
That sounds great. So because this is open source, right? So anyone can
Yes.
use this. It's all, I take it, it's if you've got Arista devices, right? So you couldn't use this against other vendors.
Not out of the box.
Not out of the box.
Someone could hack it up and to be honest, someone could hack this up and make it work in some other environment, but out of the box, it's going to be all Arista.
Yeah, and that you mentioned open source, and that's the one thing that I think I'm the most excited to work on. And when I joined Arista, Fred and Doug allowed me to open source this project that we started more from the SE side of the house to help with POCs, and formed a working group around it. And our main goal was to drive this with the community, right? So that if you look at our contributions on the repository, now we have 80 plus contributors to the repository, and that it includes customers, partners, Arista ASPS engineers that want to participate in the project. So one of our big thing is, how can we enable the community within Arista to self-sustain, but also our customers, right? If they want a feature and they want it faster, we take the time to enable them to participate in GitHub, which is something I pretty proud that me and my team have been able to enable a lot of folks to do their first pull request on a public repository.
Yeah, I suppose the other thing as well is that it's great because you guys have kind of figured out a lot of the nuances that you could even look at this project in a way to be able to kind of figure out some of the best practices. Because I know that, for example, you've built Ginger templates, so the nuances and some of the best ways to do that. So, for example, I was checking out some of your templates the other day, and I was seeing that you was using kind of delimiter-based padding as a way of then not having to then add in some of the additional Ginger, white space control options, and kind of going into the weeds a bit. But it's good to be able to kind of leverage and look into what people that have really trodden the path has done. So no, it's great. And the other thing I was going to ask is, how does this, you've got AVD, but how does that compare to something like CloudVision?
Yeah, so we see them as very complementary. So I'd say a very large percentage of our customers who use AVD today. So let me caveat this. You could absolutely have AVD run through Ansible and talk via eAPI to all of your switches and configure the boxes directly, right? And that's a very valid mechanism. But the large majority of our customers actually have AVD generate the configs and drive those configurations through CloudVision as the deployment mechanism. And we see that for a few reasons. One being they're using CloudVision anyway for all the telemetry and all the monitoring and everything like that, right? CloudVision provides them with some change control tools that they may not get if they just drive stuff straight onto the boxes. And then also, CloudVision can insert a layer of state awareness. So if I think about my typical Ansible rollout, if I put in a bunch of configs and I say, hey, Ansible, go push these out to my switches, Ansible will do its best job to push them out as quickly as it can, right? Unaware as to what the status of the network is, it's just going to shove the configs onto the boxes. CloudVision knows what the current status is of every switch in real time. So if I have, let's say, a redundant pair of switches, and I'm about to make a change to one switch, but the other half of that redundancy is down, Cloud Vision can kick it back and say, guess what? You might be trying to change this box, but its peer is down right now. You might not want to do that until your redundancy is healthy. So having that extra layer of network state awareness can be very powerful when you're trying to drive these automated changes out so that you don't shoot yourself in the foot and, change half of your MLAG pair while the other half is still in one of the switches is dead or something.
Gotcha. Now that makes sense. No, 100%. Okay, great. Well,
And
sorry.
no, I was going to add it for a lot of engineer that are new, especially new engineers that are new to automation. Cloud Vision provides that safety net, right? I'm not deploying directly to the device. I'm staging it on another system. And, in the early days of AVD, this was, completely open source, community driven. Now we have TAC support available for AVD. So now, we have the TAC capabilities, but before we did not, right? So people were just trusting this and using it, and Cloud Vision kind of provided that, like, oh, Arista will support me with, deploying things through Cloud Vision. I can rely on TAC for that. So I think that's the reason why a lot of customers like that workflow as well, right? Just that additional safety net.
That makes sense. It sounds great. It sounds really good what you guys have done, and especially like open sourced as well. So that's really great. Did you say you had a demo, like to kind of?
Yeah. We
Show
can Carl can walk you through a demo. I'll preface it with this just quick little thing that we've talked about, but I'll make a little more concrete. So what you'll see is the way the workflow goes is we start again at this sort of more abstracted model as to what we're trying to configure on the network. Then what AVD will do is sort of the first pass through here is we take this sort of network-wide model and parameters, and we then generate structured configuration for every device, right? So there's this sort of intermediate step where we go from high-level network design and parameters to switch by switch structured device models. So this will essentially contain everything that's going to be used to generate the CLI and the docs and the tests, but it's still in YAML format, so it's still structured. And then it's another pass through to then generate all of the artifacts, right? So now we'll end up with the configurations that we get to drop on the boxes, the markdown files that we talked about, the documentation, and then the tests that we will auto-generate. So just to sort of walk you through the workflow, and then I will stop sharing and let Carl take over and pop us through the demo.
All right. So at a high level here, I have my Ansible inventory. In this case, I have a data center fabric with a few spines, leaves, border leaves.
Bump the font up maybe a little.
Font the fonts. Okay, here we go. Is this good?
Yeah.
Perfect. So yeah, I have two in my fabric. I have a dual data center design with very typical Ansible inventory. And for us, we drive everything through primarily data models that are expressed in group variables. So at the top level of my fabric, I describe things that apply to all of my switches. So my usernames, in this case, I have what CVP instance I'm going to connect to, some high level parameters. In this case, this fabric is running an underlay with RFC 5549, so IPv6 unnumbered. It's very easy for me to change that. If I want to change to a typical eBGP fabric, I can basically comment these out and enable this. So let's actually do this. So let's revert to more of an eBGP design, and this kind of really shows the power of some of our network wide models that allows network engineers to express something as the routing protocol that I want to use for my underlay, and basically just focus on the design as opposed to the implementation details. So when we see this playbook being built, we will see first the structured data. So that's what we were talking earlier, what builds my configuration, my tests, etc. So this is I generated in YAML, still very readable. So that's why it's also very easy to take this data and populate other systems with it, whether it's my netbox or my IPAM system, etc. The other artifact that we generate is obviously the config. So now we can see I've changed all of my IPv6 address to an IPv4 address, and updates all of the configuration with just this simple change, right? So I can see also my BGP configuration got updated. So I'm gonna just update this to update underlay.
So the models that
Okay.
you're using, sorry. Oh, sorry, Fred.
No, go ahead,
Yep.
please.
No, it's just a quick question with the models. Is it predominantly kind of data center based networking, or do you guys support like WAN and et cetera, et cetera?
This is a very good question. So we started off data center EVPN. Afterwards, we also had requirements to build just plain L2LS fabrics. So, L2LS slash, with VRF lights, where, my spine is just doing traditional routing and no VTEPs. We've also added MPLS support with ISIS and SR. So AVD supports really multi-domain automation. And I can show actually in my demo here, I also have examples of to connect my data center. I actually have an MPLS core in the center, right? So yeah, and that's really a big driver around what we're trying to achieve with AVD. So I'll look at more of an actual use case. So here the first demo was really, and I know I'm going really fast, but I'm just high level kind of demonstrations. But something that would be more typical is adding a new VPN service, right? So over here, I'm showing you, our data model to express VPN services. This works across EVPN, across L2LS, or a WAN network as well. So let's go ahead and add a new VPN service. What's the VLAN ID that you want for your new VLAN, Rick? You have a preference number that you like?
Say 1000.
1000. That might overlap with some of our internal VLANs, but let's see. And let's just make the IP easy for now, just for a demo purpose. So by doing that, so we have these tagging mechanism. I think in the demo right now, I have that disabled, but I can apply filtering of where I want these VPNs to be on my topology. So if I have large topology, I can decide where I want these services to be deployed. We also have filtering capabilities that we say only deploy the services based on my connected endpoints that you have connected on. So I'm only going to configure VLAN 1000 if I have a port configured with an access port configured with VLAN 1000. So that's where we really provide advanced automation capabilities for the advanced users that want to leverage all the capabilities automation can bring. So with this simple change, I've added 1, 2, 3, 4, 5 lines. You can see now I've created configuration across the board for all of my leafs that have VTEPs in both of my data centers. I'll see the layer 2 VLAN being created, the layer 3 interface, the SVI, the VXLAN to VNI mapping. And in this case, I'm using VLAN aware bundle and EVPN. So I'm adding the VLAN to the bundle of that, basically that VRF. So I can see this across all the different switches, right? I'm going to see the same amount of changes being generated. I noticed here, I think let me do something quickly here in my makefile. I think to go fast, I was skipping the documentation, but that's an important piece. So let me just enable the documentation and see the documentation artifacts also being created of all these changes. So taking a step back, if we go back to DC1 and expressing the topology, these are models to define the our what we call our node types. So in this case, I have a spine and L3 leaf. So these have this is where I define my connectivity parameters and my connectivity relationships. So when I connect a leaf to a spine, I'm going to express that using a child-parent relationship. So I'm expressing here, I'm going to use these uplink interfaces. These are my uplink switches. These are my MLAG interfaces. And then when I'm defining the node, I'm going to define the links that I'm connecting to on my spine switches. I'm also defining, in this case, I'm running EVPN. I have 2 data centers. I'm considering this as one EVPN domain. I have dedicated EVPN route servers. I configured that there, and that takes care of all of the intricacies of that configuration, right? So again, if you look at this data model, a network engineer would be able to understand it. Obviously, they have to learn kind of the AVD model language, but it's still very, a network engineer, once he starts working with it, understands the parameters, and they can look at the documentation, which I'll show in a bit of how to use these models. So now I've generated all of the documentation. If I open it up in Markdown format, there we go. What we do in the Markdown is we, for each section of the CLI, we create essentially a table, and also what is the snippet of configuration. So if I go to my new VLANs, I can see the VLANs here. Why is it? Let me close out these other windows. There we go. So I can see the new VLAN we added in this table, plus the rendered CLI configuration. So from a review perspective, sometimes when I see a table format, I'll be able to identify an issue a little bit easier. And we have that, throughout the configuration for all areas. These are my layer 2 interface, my layer 3 interfaces, the configuration associated with it. So your network engineers don't have to worry about creating documentation anymore, and it's always up to date and automated every time I'm implementing a change. So it's not an afterthought, right? It's always being updated. And then we have these. So these are all the device-centric level documentation. We also create network-wide. So we also had created, changed the underlay. We'll see like the fabric topology. And if I scroll down, we'll see the IP allocation. So out of the pools that I've signed, and that helps me from a design perspective. Do I need, should, I've only consumed 9% of this IP pool. Should I, make this a /25 instead, or a /26, so assign less, less IP addresses to these point-to-point links? Or maybe I'm at 99% or 98%. I need to assign more for growth. So this could be also helpful in a planning tool. Any questions on this, Rick?
No, it's really nice. It's cool because it's a kind of, I would say documentation's definitely at like the level of like an LLD, right? So
yep,
it's really nice. And also the fact that it's in Markdown is that you got the version control on your documentation. So you've got kind of 2 places, if you like, to check any differences. And yeah.
I like to think of it as like encouraging you to get to a point where your network rollouts have versions, right? This is my data center network 1.1.1. You make a change, now you've got data center network 1.1.2, and with that comes all the configs, all the docs, all the tests, the results of the tests. You put that all together, and that's sort of your release, right? So you check that into Git, and now that becomes one timestamp in your data center or your whatever network evolution.
So here, as I was showing, there's a lot to our data models. So all of our data models are actually there's input validation with a schema and a schema language that we developed ourselves to make it easier to express, but also help us generate all the documentation that's associated on our website. So when we look at parameters, and I'm going to try to pick on what we were just doing. So if I go into our network services, let's look at VRF SVI configuration. So we have a table format that expresses all the inputs that we can have here. I can look at it in this table format, or I could look at it in this YAML format as well. So I can see the, various parameters, and I may, want to copy this, and get started. And then at runtime, we validate all of the inputs against our AVD schema that will validate, is this a unique parameter required on this list, the min and max value, etc., or if we have values that have a list of valid values available, etc. So there's a lot to a lot of input variables, and then all of this, I would say, obviously we have strategic initiatives or platforms we want to develop, but a lot of this, the new knobs that get added into AVD, is driven by projects in the field done by our PS team, AS team, or customers doing projects. On the site too, there's what we were just running through today. You can look at a dual DC L3LS example, and we'll walk you step by step what to do to create this topology. You can download this example, and make customization to it. And that's the easiest way to get started with AVD, is start with at least a base, and then just change parameters, add more nodes, more leaves, etc. So I think we have pretty good documentation to help people get started. And also we've been doing these workshops in the field as well to help automate our customers and partners to use not only AVD, but tools like Git and VS Code, and get going on infrastructure as code.
Oh, sounds good. I mean, especially the fact that you've got the schema validation, right? Because the data coming into the, let's say, workflow is super important, right? Because you don't want to be then putting bad data in, and you're going to get unreliability, you're going to get issues, right? So
exactly.
Yeah, I think it's a great point that you caught on, is that input validation is really important here, and very useful, right? So now if I fat fingered something, if I did something, if I put in a VLAN, put in VLAN 9000, it'll catch that for you and kick it back to you before you go messing things up.
Yeah. So as an example, if I make and I'm just picking on something super simple, just so that it triggers an error here, but we will, if I input my YAML a little bit, this is an incorrect key, it's going to tell me, hey, I'm unexpected key in this dictionary, right? So very easy to also help identify, what keys I've done incorrect. And, one thing that we're working on as well is a language server that will allow us to use the same PyVD validation and do this at runtime when I'm editing in a file, and not just at execution time today.
okay, great. So is that going to be like an open source tool that you're going to
It'll be an
release?
LSP plugin for VS Code. So, or actually it works with most, because I use Vim or NeoVim, and that also can suck in LSP. That's one of the reasons I was pushing for an LSP as opposed to just a generic VS Code module. But yeah.
Oh, nice. I was just going to ask a question, which I know a lot of folks that are doing network automation, they kind of ask around, and that's because there's kind of a few ways that you can configure a network, right? You know, when people come into network automation, they hear about REST APIs and they go, right, okay, this is the future. Right? Everyone wants to get away from CLI or that, you know, the config, and they think that they should be moving to REST APIs because it's structured, et cetera, et cetera. But what I'm seeing here with what you guys have built, you're actually kind of going and using more of the traditional methods of building config in its entirety to push that out. Was there any kind of thoughts on why you've taken that approach over, say, just going out to devices and configuring the devices using something like, you know, a REST API, et cetera?
Yeah, I mean, when you push directly to the device, I mean, this is cheating a bit, but when we send a payload to the device, we send it in a structured payload using eAPI, right? It is a structured payload where the config is one big blob of text with a config replace. So the key enabler of AVD is that EOS one is consistent across all of our different use cases, right? So whether it's a 8-port switch or a 7816 chassis, it's the same, you know, EOS language, you know, configuration language. And when we look at automating with AVD, we don't worry about logic of partial configuration of, especially when I'm trying to remove, you know, configuration to my switches. I'm using a config replace mechanism, which is what our, you know, our biggest customers use today in terms of pushing configuration to the devices. And I think, you know, one of the things to, because we're still working, you know, I'm still generating, and I go back to my example here. If I look at my intended config, you know, configuration, we're generating 100% of that configuration that a network engineer has worked with for the last 20 years, right? There's this enables them to understand when I'm changing these parameters, or I'm creating this new VLAN. Imagine if I just showed them a different type of payload of what I'm going to configure. It's very hard for me to understand what's potentially happening, right? But in this case, the network engineer has worked with this for a very long time, and I still believe, even going forward, it's still you still want a language that a human can read to validate that a change is correct. Because no matter how much system testing we do, even if we introduce pre-validation test cases, Rick, I know you've done a lot of stuff with Badfish. You can only test what you test for, right? And your pre-validation, you won't catch stuff that you don't test against. So you still need that human element. And I feel like by generating a config, leveraging a config replace, in my opinion, provides a lot of value for a human to still be able to understand what's happening on a network. And ultimately, if there's an incident on the network, you're going to log into the box and want to make a change. So being familiar with the device native configuration language, to me, it's still a huge benefit for the network engineers working with the system.
Yeah, I completely agree. I think having artifacts is super important, right? And it, like you're saying, for visibility, and like when you got the version control, it's a lot easier being able to do a kind of differential between a couple of configs than differential between two JSON payloads, which can be quite hard to decipher sometimes. So,
right. Yeah. And at the end of the day, the API mechanism is just the transport, right? So whether I'm using a REST API, whether I'm using JSON RPC, whether I'm pushing this through CloudVision, that's sort of just the transport mechanism to get your configuration changes into the box. But this is so much more than that. This is really thinking about the bigger picture of how do I not think about it on a box by box level? So that's a major component here, right? The fact that Carl made, I don't know, 5 lines of change and it touched 44 different files to do that. That's really huge. I don't have to think about modifying 44 individual files anymore. And then to your point, if this is all REST API calls, how do you rationalize individual REST API calls into a diff that I want to go back and review? Or when I'm trying to, put together some kind of documentation or something, how do I reconcile that a bunch of REST calls together into documentation?
Yeah, 100%, 100%. So
Yeah, and
it's sorry.
no, I was just gonna add, just to support this kind of thought, and just with an example, I think examples are great. Like, hey, as a network engineer, my intent is I want to configure multicasts on my underlay. For us, it's basically, okay, you go look in the documentation. How do I do this? Underlay multicast, make it true, and that will take care of implementing that feature across the board. I may actually learn, what's required from configuring this manually. A lot of my engineers have actually, I was speaking with one yesterday, says like, hey, I did not know how to configure EVPN multicast. I looked at AVDs, was, 2 simple knobs to enable this. And I actually learned all the, the configuration required to enable that feature, but without having to look up, all the documentation and make sure I do this right. So, if you look at, again, I did one single line change, and now I've enabled PIM IPv4 sparse mode across my interfaces. And then, I'm enabling router multicast across my devices. I'm doing this consistently. I've updated my docs to support that as well. So again, very powerful way to express, your network wide model, but still see the device, what gets generated at the device.
Yeah, it's really great. It's really great. I'm definitely going to have to kick the tires with it as well. And especially like, combining, if you want to kind of start kicking the tires using something like Container Lab with your Arista containers as well, it seems like a great way to get started, right?
Definitely.
Oh yeah.
And our documentation is all at avd.arista.com, so it's pretty easy to find.
Great. Well, no, I really appreciate you taking the time and sharing this today. Was there anything else you wanted to cover before we wrap things up?
I think this covers quite a bit in a short amount of time, and we're always happy to follow up with folks. I think people can figure out, can get a hold of us. You can just email us. My email is fredlhsu@arista.com. Carl's, I think it's carl.buckman@arista.com. We can post contact links somewhere in the notes or something if you need to get hold of us.
Yeah, sure thing. Well, that's great. No, I really appreciate your time today. It's been great to see, and it's great what you've put together. So yeah, nice work, and yeah, I appreciate your time today.
Thanks,
Perfect.
Rick. Thanks for having us.
Thank
Cool.
you, Rick.